So today we're going to talk about conditional statements. So what a conditional statement is it is in if-then form. So for example, we have a statement, if a car is a Corvette, then it is a Chevrolet. So we have the notation if P, then Q. So P implies Q, or our hypothesis implies our conclusion. So P would be our hypothesis and Q would be the conclusion. To determine your hypothesis and the conclusion, the hypothesis comes after the if statement, and then the conclusion comes after the then statement. So if we pick it apart, we have if a car is a Corvette, then it is a Chevrolet. So a car is a Corvette is the hypothesis, and our conclusion is it is a Chevrolet. So if we notice that the if and the then are not part of the hypothesis or conclusion. So if you're asked to just list the hypothesis or you're asked to just list the conclusion, then you're just looking for the statement that comes after the if and after the then. When we're talking about our conditional statements, we get four statements that occur with that. We have a conditional, we have a converse, we have an inverse and contrapositive, and then we have truth values. So the conditional and the contrapositive always have the same truth value, and the converse and the inverse always have the same truth value. So for example, we have the conditional, which is if a figure is a rectangle, then it has four sides. That is a true statement. A rectangle has four sides. Now, the converse of that, we're switching the hypothesis and the conclusion. So if it has four sides, then it is a rectangle. Now, that's not necessarily true because we have other shapes that have four sides. So for example, I could say a square. So that is a counterexample, which would make the converse false. Now for the inverse, we're taking the conditional and we're negating it. So we're making it say not or don't, some form of not. So the inverse would be if it is not a rectangle, then it does not have four sides. And again, that's false because just because it's not a rectangle doesn't mean it can't have four sides. Again, a square would be a counterexample. And then the contrapositive, we're basically just flipping the inverse. So we're negating the hypothesis and the conclusion, and we're switching them. So the contrapositive would be if it does not have four sides, then it is not a rectangle. So now we're just going to practice writing the four. So first, again, we're going to start with the converse. So the converse, again, you're flipping the hypothesis and the conclusion. So if we flip, if you want to be healthy, then you should eat vegetables. That's going to look something like if you eat vegetables, then you want to be healthy. Again, you're switching the hypothesis and the conclusion. Now the inverse, we're going to negate the hypothesis and the conclusion of the conditional. So I'm looking at that first statement, if you want to be healthy, then you should eat vegetables. And again, I'm negating both. So it would look something along the lines of if you don't want to eat healthy, then you should not eat vegetables. Or if you do not eat healthy, then you should not eat vegetables. And then lastly, two ways you can think about it. You can think about the contrapositive as you're flipping the hypothesis and the conclusion and negating, or some people like to think of it as just flipping the inverse. So if you don't eat vegetables, then you don't want to be healthy, would be the contrapositive. So what I would do here is go ahead and pause the video, try to write all three out. Try to write the conditional, the converse, the inverse, and the contrapositive. And then when you're done, check your answers. So again, go ahead and pause, write, and then when you click the play button, I will pull the screen down so you can check your answers. So go ahead, check your answers there and see if what you need to fix. Again, the wording could be a little bit different, but the biggest thing you want to pay attention to is if the hypothesis and conclusion is switched, that you have it flipped, and if you're supposed to negate it, that you have it negated in some way, shape, or form. So for the next example, we're kind of going to look at truth values here. So you'll have to write in the converse, inverse, and contrapositive, and we're going to talk about the truth values. So if an angle measures 80 degrees, then it is acute. That is a true statement because the acute angle is anything less than 90. So 80 degrees is that as well. Now we have the converse, which is we flip the conclusion and the hypothesis. So if an angle is acute, then it measures 80 degrees. Now, although that's true, we can think of a counterexample, because just because it is acute doesn't mean that it has to measure 80 degrees. It can measure anything from 1 degrees to 90 degrees, or to 89 degrees, sorry. Then the inverse, if an angle does not measure 80 degrees, then it's not acute. So again, a counterexample would be if it was 50 degrees, it's still acute, so it doesn't have to be 80 to be acute. And then lastly, if an angle is not acute, then it is not 80 degrees. So that's, again, true, because if it is not acute, then it can't be 80 degrees because it can't be anything less than 90. So that would be a true statement. So that's how you're going to put truth values in, is you're looking for a counterexample to make the statement false. And remember, the conditional and contrapositive have to have the same truth value, as well as the converse and inverse. They could all be true and they could all be false as well. That is an option. Now we're going to look at Euler diagrams, or pretty much Venn diagrams. So the first one, we're going to go back to that first example. If a car is a Corvette, then it is a Chevrolet. So we're looking here, our hypothesis is going to go inside, and then our conclusion goes outside. So since all Corvettes are Chevrolets, and Corvettes are just a piece of the Chevrolet line, this is what the Euler diagram would look like. So the Corvette would go inside the circle, and then Chevrolet would go outside the circle. So again, if you want to make a note here, your hypothesis goes inside and your conclusion goes outside. So we're going to look at an example here. The first example is, if the ground is wet, then it rains. So again, my hypothesis is the ground is wet. So that is going to go inside my circle. So wet ground is going to go inside the smaller circle. That's my hypothesis. And my conclusion is it rained. So my conclusion is going to go in the outer bubble. So go ahead and fill in the next one. The hypothesis is the trees are moving. So that's going to go in the small circle. And it is windy is our conclusion. So that's going to go in the outer circle. Now we're just going to do this backwards. So we're going to write the statement now given the Euler diagram. So we have Taylor Swift inside the smaller circle. So that's going to be my hypothesis. And we can kind of make up whatever we want here. So I'm going to go with, if I am Taylor Swift, then, and my conclusion is going to have to be something with celebrity. So then I am a celebrity. So on the last one, go ahead and try that one on your own. So pause it and see what you can come up with. An if-then statement with Lil Wayne in the small circle and rap music in the larger circle. So take a minute to pause it, and then I will undo the screen when you play it so you can see the correct answer. So the correct answer is, if I listen to Lil Wayne, then I listen to rap music. Again, you can have different words there. You're creating it. Just make sure that you have Lil Wayne in the hypothesis and rap music in the conclusion.